a kind of the conceptualized relationships between the agronomic inputs, like in fertilizer and seeding, or in herbicide and chemical uses, and the crop yield. So the crop response could be variable from place to place. So for example, the site A, sure, there's the point. So site A might be more responsive to the input rates than site B. And in this case, the optimal input rates are not the same between the place. So what we have to do is to, we agronomists must understand how these crop yield response could be variable from site to site to make to support the decision making of farmers to optimize the agronomic input rates, like in fertilizer and seedings. And in these case studies, I would like to show the analysis on the fertilizations primarily. So how to achieve this is we might have to conduct some experiments. And this is not only in the research institute, but we also have to conduct some experiments in farmers' field. So there's an urgent demand that the experiment should be applied in the farmers' field. So what so-called the on-farm experimentations is now spreading worldwide. And now I'm presenting one of the examples that is frequently applied methodologies in the United States. So, for example, this is the case of the data incentive farm management project supported by the USDA. So, in every year, the American farmers are doing some experimentations on their own field. For example, in this case, actually, this is not a case of the America, but it's in the Argentina, so Latin America. And due to the development of precision ag in the Western countries and some Southern African American countries, they can quantify the crop yield using the yield monitoring systems mounted on the combine harvester. And they can also apply a different rate of the fertilizers or some chemicals or the irrigations using the variable rate application equipments. So what they can do is they can set up the experiment by themselves. So previously, the scientists can only conduct some experiments in the research institute, but due to the development of the precision ag, everyone can conduct the experiments. So by doing so, the farmers can identify what is the best rate of the fertilizer applications in each place. And at the same time, they can also see some other treatments, like the seeding rates. In this case, they are trying to explore the best seeding rates. And they can also see some other effects of like an herbicide or some application. Okay. Okay.
The committee, maybe something like the voice, please.
Okay, so an ICCC may be discussing about the issues of the global warming. So due to the unstable conditions of the climate and unpredictable weather, the old conventional and traditional crop management should be changed. And so we must optimize the crop management everywhere, but all the scientists cannot do experiments in every field. But if these on-farm experimentations could successfully provide information to the farmers, then they can devise their crop management systems by themselves. So there is an urgent interest in the on-farm experimentation now. But here are the things. We must know the economically optimal input rates to maximize farmers' profits and to calculate or to evaluate the most profitable agronomic input rates. We must know the causal relationships between the agronomic inputs and crop yield. And in recent years, many researchers using machine learning to understand the causal relationships between them. But yeah, actually, nobody knows which machine learning should be used for analyzing non-farm data. And the final objective of establishing machine learning models to predict the crop yield is not to just predict the crop yield levels, but also we have to see how much yield could be changed by adjusting your farmers' input rates in their own fields. And given that the price of the crops and the price of the fertilizers is constant, then if we could evaluate the changes in crop yield at the certain or specific input rates of the fertilizer, then we can understand how much marginal profits could be obtained by changing the agronomic input rates. So what we have to see is to create or establish the crop yield response model to predict the crop yield level, and then we apply a kind of the sensitivity analysis to find the maximum marginal profit values that could maximize the farmer's profits. But the problem is that machine learning is not telling us the true value of the economically optimal fertilizer input rates. And in this case studies, it shows that the x-axis shows the yield prediction level estimation errors, RMSE values. So now in these studies, we compare different types of the machine learning models to evaluate the yield levels and economically optimal fertilizer input rates. So if RMSE value of yield prediction is low, then that machine learning algorithm is working very good. On the other hand, y-axis is the prediction accuracy of the economically optimal fertilization rates. And then what we could see is that so this one represents the CNN. CNN is one of the very famous deep learning model, and it can actually predict the crop yield very precisely, but it cannot provide any good answers for making the decisions on the fertilizations, because it shows a very high estimation errors for economically optimal fertilization rates. So the good yield level prediction does not necessarily lead to the good economically optimal nitrogen rates predictions in general. And in this study, what we have done is that we use the synthetic data, and we use this kind of mechanistic model equations to make a synthetic data. And then after making the synthetic data, we apply different types of machine learnings and try to compare the prediction accuracies among different machine learning models. So we assume that here is 51 hectares of the crop field, and each blocks may have different crop yield responses, and these equations can provide the different crop yield responses to the agronomic input like fertilizations rates. And so by using the Gaussian statistical simulations, we can make the spatially variable input of these different types of the coefficients to simulate the crop yield response like this. So some areas may have the very strong responsiveness, but the rest of them are not. But this kind of research is very based on very simple assumptions, and this does not account for the seasonal impacts. So we might have to generate more and realistic synthetic data to compare which machine learning model is good for predicting crop yield level, or some to optimize the optimal nitrogen input rates. So in this study, I have used a crop simulation model to account for the temporal changes that is affected by weather data. And we use the crop and process-based model they called in Wolfos that is developed in Wageningen University for a long time. And it can simulate the daily crop growth based on the weather data and soil data. And so the carbohydrate that is photosynthesized will be distributed to each organ day by day, and we can predict the crop yield by accounting for the temporal changes. And here we assume that same as the previous research, I have assumed that there is 51 hectares of the cornfield in the United States, and we assume that this is in Illinois State. And we changed the different types of the parameters of the crop simulation models, and one of them is the depth of the roots. This is related to the water availabilities, and the total dry weight and initial total dry weights reflects the initial crop growth status, which means the number of the seedlings that has been established just after seeding. And nitrogen availability is directly related to the fertilities of the soil. Yeah. So by using those different types of the parameters, and we assume that each parameters may have the different spatial variabilities. And I also have to apply the different rate of nitrogens into this model, and then we can gain different crop yield responses. And also we have to add the weather data. So for the weather data, we collected the 42 years weather data from the DAMES at the Illinois states. And so we simulated the different crop yield responses, and spatially and also temporally over the 42 years. And here's the result. So this is one of the results that I've got, and so we gave the same soil properties, but we applied different weather data for these simulations. And as you can see, if we apply different rate of nitrogens, then we will get the different spatial variabilities of crop yield. And this is the example in 2000. And if we see the different crop yield responses over the time, so there is a 42 years different simulations at the same size. So as you can see, even though the soil data are the same across the years, the crop yield response are substantially, so it's significantly different among years, which means this indicates that it's very difficult to identify which is the best amount of the fertilizer that should be applied to maximize the crop yield or to optimize the farmer's profits. And this is the result of the space and time variations of the economically optimal nitrogen rates. So some years, like in 1985 or 2004, the farmer should apply more and much fertilizers, like more than 200 kilograms per hectare. But in, for example, in this case, 1991 or 2011, the fertilizer shouldn't be applied so much. It's almost around the 150 or to 100 kilograms per hectare. Yeah, so actually there is spatial variations of the economically optimal nitrogen input rates, but that is more sensitive to the weather data, even with the same soil parameters. So here are the questions. The on-farm experimentations can be used for the optimizing the farm crop management because it's temporarily very variable. So here are the figures of the box plots. This shows the temporal variabilities of the economically optimal nitrogen rates, and it begins from 1980 to 2022. And if we see the recent years from 2018 to the 2020, then the economically optimal nitrogen rates are not temporarily variable. But if we see the in the long term, so the economically optimal nitrogen rates are very fluctuated based on the year. So once, even though you can predict the economically optimal nitrogen rate using the good machine learning model, that cannot be used to predict or to make the recommendations for the next year because the difference is quite large among the year X and year X plus 1. Okay, so now it's almost a time maybe. And this economically optimal nitrogen rates are very sensitive to the climate data. And so in this figure, it shows the cumulative irradiance. So it shows how much the plants can photosynthesize using the sunshine. And the y-axis shows the cumulative precipitations. So if this precipitations is very low, maybe in that year, the crops suffer from the drought stress. So in this case, the colors of each circles indicates the difference of the economically optimal nitrogen rates. And in dry year, farmers shouldn't apply too much fertilizers because the economically optimal nitrogen rate is almost 0 to the 50 kilograms per hectare. But even though this weather is quite similar each other like what see these areas, the weather data are almost the same, but economically optimal nitrogen rates are not the same. So it means that it might be very difficult to predict the economically optimal nitrogen rates, even though you know the weather data. So here I'm going to summarize my presentations. And the first thing is that the spatial distribution of the economically optimal nitrogen rates within the field will be substantially variable according to the weather data, the weather conditions. And the outcomes of the on-farm experimentations may not be reliable for the other seasons, and although the machine learning that could predict crop yield levels very precisely. So to optimize the crop management based on the experimentations, we must consider the different aspects. For example, we shouldn't, or we might not be able to optimize the crop management like the base of fertilizers or seeding rates, just like in the crop management that will be applied in the early stage of the crop growth. But we might be able to improve the crop management in the later growing seasons, like in top dressing at the flowering stage or some later growth stages. Because uncertainty of the weather would be decreased in the later of the crop growing seasons. And at the same time, I will skip this one, we might have to consider the impact of the irrigations, not only on the fertilizations, but also the impact of the irrigations should be considered when we are trying to enhance the economically optimal nitrogen rates. Because irrigation, so in the previous figure, what we can see is that drought stress is very strong, the determinants on the crop yield response and the economically optimal nitrogen rates. And if we could apply the irrigations precisely while optimizing nitrogen input rates, so these two different crop management should be coupled to optimize crop management. So we shouldn't go only for the fertilizations, but we also have to go for other crop management to optimize the total crop management practices. Okay, so I think that is almost 20 minutes. Or time over. Yeah. Thank you. Thank you very much.
Thank you very much, Sensei, for your nice presentation. So from the Tanaka Sensei, we know that the topic about space-time variation in crop yield responds to the fertilization. So from this topic, the understanding of crop yield response to crop management of environmental factors would contribute to better decision making, which can enhance profit while reducing environmental load. So from this presentation, we learn that spatial distribution of EONR would be sustainability variable according to the weather conditions, and then the on-farm precision experiment may not be reliable for the other section, although the NL code predict yield level and EONR very precisely. Okay, Sensei, maybe it is very nice presentation, and enhance our insight for this topic.
Trial.
So let me inform you again for the audience. Maybe if you have any question or maybe any something for us, you can take a note and then we can asking and then discussion in the last in the after all the presenter will be present. Okay, so you would like to move to the next presenter, maybe. Before I
Trial.
there is some feedback. Before I like to invite the next presenter, maybe let me read the CV from the Tanaka Sensei course.
Trial.
Tanaka Sensei is Professor Dr. Takashi, the name is Takashi Tanaka, and then present position is Associate Professor, and then from the Department of Crop Science, University, Japan. Expertise in soil and crop science. I'm sorry, Sensei, I late for reading your CV because unfortunately there is something trouble, so I read your CV. So move to the next presenter, maybe already Miss Ibu Mani.
Trial.
Yes,
I'm here.
Okay, Ibu, let me read your CV.
Trial.
Okay. Thank you for coming. So the
Trial.
education requirement for bachelor. Could you please help me, committee?
Trial.
To solve up the. Okay, thank you so much. So education background is bachelor from Soil Science Lasma University, and then get the master from agroclimate APB University, and then get the doctoral is from the agricultural science from Sebelas Maret University, and then a lot of research she already conducted during these years, every years. So maybe a lot of the research maybe I couldn't read which, but for example, is evaluation of cropping pattern in Pranotonongko based on and land water balance and several aspects in
Trial.
Okay, maybe for could you please help me, committee, for the noise points coming our conference? Okay, thank you so much for your
Trial.
helping. Okay, maybe without any there is something noise. I'm sorry.
Trial.
Okay, without any other. So come, please, Mrs. Ibu Sumani, please come to the desk. Time is yours.
Okay. My voice is
Trial.
Yes, quite clear.
Okay. Thank you. Thank you,
Very
Miss
clear.
Adriana. Okay. Good
Trial.
afternoon, the best and the best wishes to all of us. It is a great honor for me
Trial.
let me share my presentation.
Trial. Trial.
My slide is visible?
Yes.
Okay. Okay.
Trial.
Okay. First of all, let me introduce myself. My name is Sumani from the Soil Science Department,
Trial.
Faculty of Agriculture, Universitas 11 Maret. I'm going to present my paper entitled Climate Change Effects on the Cropping Patterns of Rice Fields Lands in Central Java. There are several things to consider in relation to my paper.
Trial.
Climate change has caused shift in rainfall, both in terms of when and where it occurs. As we know, precipitation is very important for agricultural productions. Hence, the uncertainty of precipitation may promote the uncertainty of growing period of rice and other agricultural commodities. Cropping patterns are highly dependent on weather conditions. The cropping patterns is also defined by the climate trends. Therefore, it's important to identify changes in climate parameters. Several studies have been carried out previously in Central Java regarding climate change. Among others, Pramuda and Onisi reported that in 2015, there was severe drought in Central Java, specifically Tegal City, using SPI. Kumaria and team found that air temperature increase in associated with drier air at part of Central Java due to land use conversions from rice field to residential. In 2016, Nugroho and Nuraini conducted research on determining cropping patterns based on water balance. From the result of this research, they provide recommendations for cropping patterns as follows. The first, at the first planting season, paddy, corn, soybean, and paddy. And to type, paddy, corn or soybean, and corn or soybean. And the third type, corn, soybean, all the year. The first method is recommended for areas with sufficient water availability. The second method is for areas where rainfall is less than the first area. And the third method is for areas with little rainfall and no irrigation facilities such as reservoir. The background of our research, which shows its novelty, is the diversity of climate, mainly rainfall, and several topographies and Central Java regions. The physiographic conditions of topographies are very different, so the climatic conditions are different too. It is interesting to examine how climatic changes different topographies, especially changes in rainfall, considering that rainfall is the main source of water to support agricultural activities in rain-rich areas. This is a map of Central Java, Indonesia, where our research area includes topographies of volcano in the regions. Lowlands are shown in green. There is an altitude of less than 400 meters above sea level. Lowlands are shown in yellow. An altitude 400 to 700 meters above sea level, and highland areas shown in red, an altitude of more than 700 meters above sea level. Our study was carried out through rain data analysis which is secondary data taken from rainfall stations owned by Watershed Research Center for the Central Java regions, Indonesia. Rainfall data analysis uses data from 2009 to 2019 to obtain information on monthly rainfall characteristics in highlands, mediumlands, and lowlands. Based on the characteristic of rains, the planting patterns is arranged in accordance with the availability of water from the presence of rain in the area.
I'm sorry, Mr. Wani, could you please make a slide show from your presentation? Sorry for interruption in the middle. Thank you so much. Yeah,
okay,
thank you.
Sorry.
Yeah, please go ahead. Yeah, please go ahead.
Okay. To find out indication of climate change, climate data was arranged into 3 periods: data for 1990 to 1999, 2000 to 2009, and 2010 to 2019. So the changing trend is visible. The research shows that in all topographies, both highland, mediumland, and lowland experience a decrease in average rainfall during these 3 periods. Based on this, the cropping patterns is evidenced not only for paddy, but crops or horticulture and short-lived vegetables. These are the results of observation on upland, midland, and lowland topographies regarding some climatic parameters, especially temperature and rainfall, and several soil properties such as permeability, soil acidity, soil organic matter, soil porosity, soil bulk density, and soil texture. The physical characters of the soil greatly affects the ability of soil to hold water, so that it will affect the availability of water to plants. Rainwater that falls to the ground will be retained by soil so that it can be available to plants. This table shows the recommended cropping pattern for rice based on seasonal precipitations. Recommended planting patterns based on plant water needs, which are available from rainfall are presented in table 2. In highland and meadowlands, planting seasons 1, rice, and the second planting seasons, rice, and third planting season is fallow. Meanwhile, in the lowlands, in the first planting season, rice, in the second planting season for secondary crops and short-lived vegetable horticulture. But in real conditions shown in table 3, farmers apply the following pattern planting pattern. High plant all year round, secondary crops and vegetable horticulture. In the middle land, rice planting first rice planting season 2 and 3 of secondary crops, and the lowlands or year-round rice. This can happen because many efforts are made to provide irrigation water. In the lowlands, irrigation water is available from reservoirs and deep wells. In the middlelands, farmers make deep wells, small water reservoirs. In the highland, farmers channel water from springs to irrigate their land. This figure shows several efforts to fulfill plant water needs to support the implementation of cropping patterns of 3 plantings a year through rainwater harvesting as farm water reservoir, namely Embung, and small farm water reservoir, namely Embung Mini. Also making deep wells, channeling water from springs through pipes, and so on. This is a graph showing productivity of several crops on lowland, black grapes, in midlands, gray grapes, and highlands, slanted line grape. Rice productivity in lowlands is higher than in the middlelands. Rice is not cultivated in the highlands because the topography is hilly and the soil structure is porous. Corn productivity on the 3 different lands are not significant, although it appears that the average in the lowland is lower than the middle and highlands. The conclusions: precipitation volume at all toposequence of volcano areas in Central Java decreased over a period from 2009 to 2019. The season on-site slightly came late than previous period, but didn't change actual cropping patterns by farmers, where the crop selection and cultivating period has been determined by the efforts to meet irrigation water needs through rainwater harvesting, such as farm reservoir, small farm reservoirs, deep wells, and others. Agricultural water management, incorporating with cultivar selections, are very important in achieving agricultural productivity. Thank you. Ms. Yana?
I'm sorry. Thank you very much, Ibu Sumani, for your next presentation. So from the climate change effect on the cropping pattern of rice field line in the Central Java, Indonesia, we know that precipitation volume of all toposequences of volcano area in Central Java decreases over the period from 2009 until 2019, and that the agricultural water management incorporating with cultivar selection are very important in achieving agricultural productivity. So thank you very much, Mr. Sumani, Dr. Engineer Sumani, MSc. So your presentation is really increase our insight about the climate change effects on the cropping patterns. So because of the panelists already present of their topic, so about the audience. If there any question or maybe something that you would like to question, please asking to Ibu Sumani or maybe to Tanaka Sensei. Is there any question from the audience? Still? No? Okay, maybe let me ask to the Tanaka Sensei. Sensei.
Halo, Bu Andriana.
Oh yeah.
Can I ask? Can
Yeah,
I
sure.
ask to
Sure,
Ibu
please.
Sumani? Yeah, it is very interesting presentation, Ibu Sumani, especially about Pranoto Mongso. It's the kind of climate that Bumani has feeling with those conditions. And my question is, in this condition, especially El Nino condition, how we can choose the step of Pranoto Mongso that connected with El Nino, Bumani? Because you very experienced, you have experiences on Pranoto Mongso. Just one question for Bumani. It's a good presentation. Thank you.
Thank you so much, Prof. Sophie. Okay,
Yeah.
maybe directly answering. Bumani, monggo.
Okay, thank you very much, Prof. Budiastuti.
Yeah.
Okay. Pranoto Mongso as local wisdom. It's still relevant in this day because we can get more information from physically condition in our environment, and we can study these conditions, and we can get related on this. Especially in information of rainwater, because it is the most important for suggesting agricultural production. Thank you. You were still mute? You are still mute?
Sorry.
Okay.
Okay. It is my feel too about this condition, especially this El Nino condition make a high temperature that make the plant can grow well. So we have to have some kind of like how to make the plant grow well when the temperature is so high. Thank you, Bumani, and I will learn more about this Pranoto Mongso from you.
Okay.
Thank you, Bu Andriana.
Okay. Is there any something to say from Ibu Mani?
Okay. Okay. I will to cope with climate change. Farmers are trying to take adaptation and mitigation. Yeah. And selecting adaptive crop and get rainwater harvesting. The example, adaptive crops in Indonesia, there are low emission rice varieties, Cihirang varieties, and also varieties that are resistant to water shortage, such as Inpago, and varieties that are resistant to excess water is Inpara. we get adaptation.
Okay, thank you very much, Ibu Mani, for your explanation and nice presentation about Pramoto Mongso. Okay, thank you. Maybe is there any question from audience? Maybe directly.
The presentation from Mr. Tanaka is very difficult for me to understand. Sorry. Very difficult to understand. It's it's very high experience from Mr. Tanaka.
Very.
Yeah. I honest with this condition.
Same as me, bro. So maybe let me asking for Tanaka Sensei. So maybe it's not make sense for you, but I didn't understand too. But I try to understand about how to say EONL. Actually, I didn't know about the EONL, so I try to search about EONL. It's not wrong. It's Observed Economic Optimal Rate. Is it true, Sensei?
Yes. Do you hear me? So EONR is the metrics that can provide.
Okay. So this EONL is focused on economically optimalization input or maybe observe the nitrogen. So how can during this situation, for example, is El Nino situation, nitrogen is very calculated in this your research.
So that's because the sound quality is very bad, so I couldn't catch what you were asking me. But are you asking about how I calculate the EONR?
Yeah.
Yes. So
it's EONR.
So EONR is the nitrogen rates that maximize the farmer's profits. And the necessary parameters is the yield at the given nitrogen rates and the prices for the fertilizer and the grain yield. And so you can balance between the revenue and the cost. So the variable cost can be obtained from the fertilizer rates, and you can multiply the fertilizer rates by the unit cost for the fertilizer. And the revenue can be evaluated as the grain price and the crop yield in a given nitrogen inputs. Then you can subtract. You can apply subtractions between two parameters. Then you will get the profits that the farmers will gain. So if you have the crop yield response model using the machine learnings or some crop simulation model, then you can simulate what is the best nitrogen input rates to maximize the farmer's profits.
Okay, so for your maybe I would like to accept your answer is for the management of input of the absorption of nitrogen, it can mitigate the climate change, something like that. So the optimization of nitrogen absorption for the plant is one way for the mitigation the climate change.
No, that's I'm not talking about the climate change actually, but what I want to put and emphasize on my research is that the profitability, so farmers' profits can be largely determined by the nitrogen inputs, and these decisions could be very altered and variable due to the weather changes. So it depends highly on the weather in that year. So if the climate change affect the normalities or the abnormalities of the weather condition, then it can also contribute to the changes in optimal nitrogen rates in the future. And so, yeah, farmers needs to know what is the best crop management from their experimentations, and that's rates. So input rates could be changed due to the climate and also climate change as well.
Okay. Okay. So the management of the fertilization, it makes profit for the farmer.
Yeah.
Okay, I see. Okay, so is there any question from the audience? Maybe something like something unanswering in your mind. Maybe you can ask it over here. From the Zoom, is there any question? No. Okay, maybe because no question.
Yeah, no more question.
No more questions. Okay. Thank you so much for your nice presentation from Tanaka Sensei and then Ibu Sumani. Very nice topic for this climate change, for this conference today. So finally, all of the questions, 2 questions already have been answering and by all the panelists. So thank you very much, Tanaka Sensei and then Ibu Sumani. And then I would like to apologize if during this session, is there something mistake or maybe uncontrollable, unconditional thing. So I would like to give the time to the MC. Thank you so much.
Bu
Thank you,
Andriana.
Miss.
Bu Andriana,
Yes.
can you help me? Let me introduce, let me join to room 1. Yeah,
Room 1.
please
Okay.
tell the operator maybe, because I have to, should be in the room 1.
Okay.
Yeah. Thank you.
Terima kasih, Je. Monggo. Okay, thank you. I would like to. Okay. Please, MC. Time is yours.
Okay, thank you, Miss Andriana, Dr. Sumani, and Dr. Tanaka. Then, Excellencies, distinguished guests, ladies and gentlemen, before we close the opening ceremony, we have assembled a remarkable lineup presentation that will be developed into a wide array of topics in the Zoom room, including the first is impact of depletion or enhance of a capability of resources of air, water, and soil and vegetation in room 1 and room 2. And then we have strategy for environmental disaster reduction research, climate model and uneven precipitation distribution, pollution and contamination of land surface and atmosphere, carbon footprint, greenhouse gas emission, recycle and reuse energy research in room 3. And then we have direct and indirect risk of well-being in room 4. And we have the implication of climate adaptation and mitigation research, infrastructure risk and planning on climate adaptation, marine ecosystem affected by climate change in room 5. We hope that the 9th International Conference on Climate Change 2023, linking climate change and environmental securities, serve as a catalyst for change, inspiring us to redouble our effort, innovate with a purpose, and work together to ensure a sustainable and resilient future for all. We believe through interdisciplinary collaboration, technological innovation, and sustainable practices, we can create a brighter futures for the next generation. Together, we can make a difference and leaving a lasting legacy of environmental stewardship. Last but not least, let me give a little rhyme for you. Some monkey stealing apple pie. I press the button to open the gateway. I promise this is not a goodbye. I'm Sophie and all the crews want to say enjoy your day. We will see you again in the next ICCCC agenda. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Mana nih nggak dipindah ke room 1?
Bu, sampun di itu kan
Gimana?
disampaikan. Sampun